Before European colonization, Australia's rainforests were largely intact.
Complexly intertwined ecosystems rich in biodiversity, flourishing with life. Not only a vivid beauty, but a crucial habitat, a source of food, and a necessary carbon sink, absorbing greenhouse gases in the air and exchanging them for oxygen. Now, almost half the rainforests in Australia have been destroyed.
Rainforests are important as carbon sinks because they absorb and store the CO2 through the photosynthesis. That organic matter is quickly decomposed and reabsorbed in the ecosystem. So carbon sinks are very important to support life on Earth because they not only absorb and store the carbon, but also they help to regulate the temperature in the Earth and help mitigate climate change. Rainforests are essential to life on Earth.
But over 40% of Australia's rainforests have been deforested due to clear cutting, primarily for the purpose of agriculture and industrial development. The state of Queensland specifically accounts for over 60% of Australia's total clearing, making it the state with the highest rate of deforestation.
Because of this history of deforestation, there's been a lot of interest in implementing revegetation sites throughout far North Queensland. Over the last 20 years, there's been a lot of revegetation sites in previously cleared areas, making it the perfect spot for us to do our revegetation study. Our goal is to compare revegetation sites with high and low human disturbance rates. One of our sites was Donaghy's revegetation site, which is considered to be the prime example of a site with very low human disturbance rates. Conversely, we also have a revegetated rainforest plot in Dunganville Park, Malanda, which is planted in an urban area and has relatively high disturbance rates. To have a baseline of how well these revegetation plots are doing, we also wanted to see the difference between those revegetated plots and a reference rainforest plot in Malanda.
The area that we're sitting in now, in the 70s, this was completely cleared, and over 90s and early 2000s, there were a couple of revegetation projects. The local council and local landholders started planting this area out, and then it kind of just disappeared from everyone's memory, and not much work has been done on the site since. And there's a really good canopy now. But that means that the weeds that are dominating the understory, it's really, really hard to get those seedlings to grow because there's not much light. There's a lot of competition. So that is going to be a struggle. I think one of the most important things is, not just seeing it as putting a tree in the ground, but it's a longer term effort.
To determine the differences between the different revegetated areas and the mature forest, we analyzed similar sized plots in each of the sites, identifying the species, height, and diameter of the trees.
We expect to find a difference in the species composition, predicting that the Dunganville plot will have the lowest, and the reference rainforest will have the highest. We also expect to find more weeds in the Dunganville plot, considering that it is closer to a residential area with an increased amount of human disturbance, compared to the Donaghy site, which is more closed off and isolated.
One of the things we look out for when we are examining if rainforest restoration is successful is by looking for rainforest specialist species such as a little seedling here, and it's actually a seedling of what's known as a blush walnut, which is a rainforest specialist tree. And this is one of the kind of things that we would like to see coming up when we do rainforest restoration, because it's an indicator that the rainforest is coming back.
To determine the differences between the different revegetated areas and the mature forest, we analyzed similar sized plots in each of the sites, identifying the species, height, and diameter of the trees.
This is 31.55. This one's 2.0.
As we predicted, one of our most significant results was an increased amount of weed species in the disturbed plots as compared to both the undisturbed and the mature rainforest. This significance to weed species suggests that proper management and lack of disturbance, like in the undisturbed site, can actually decrease the amount of weeds present. This metric also further reinforces the similarity in composition between the undisturbed site and the mature rainforest. We observed a decrease in early pioneer successional species in the disturbed site, which we believe is due to an increase in weedy species taking its place. We also found more vines and mature phase trees in the undisturbed site, similar to the mature rainforest, whereas the disturbed area came up short. We believe these key differences in rainforest composition demonstrate a slower progression of the disturbed site towards what is to be expected of a mature rainforest.
The species composition dictates that the minimally disturbed site shares more species with the reference forest than the highly disturbed site, even though these sites are closer spatially, emphasizing the effects of secondary succession and planting methods on these groups.
Although the composition between all three sites remains different, the basal area and the biomass between all three sites are very similar. Even though the disturbed areas do not look like the mature rainforest, they still provide critical rainforest ecosystem services, including providing a habitat, providing shade for later successional species, restoring biodiversity, and acting as a carbon sink.
In the end, our takeaways from this research are that undisturbed revegetation efforts can reflect mature rainforests, while disturbed rainforest sites tend to be more weedy and compositionally different. However, prioritizing revegetation as a whole is so much more important. Tree planting, whether disturbed or undisturbed, can positively impact the species and community it inhabits. Reforestation on any level is critical and is a net positive, but using this data to make more scientifically informed revegetation efforts in the future to make rainforest revegetation more efficient, effective, and holistic.